Next, we're going to do some more trig graphs. Now, so first cosecant, that's the inverse of sine. So we're going to start by graphing sine and then graph the inverse. So first, you're going to do the same as you did before, where it's 2 pi over the frequency, over 1/2. So it gives you 4 pi divided by 4. Your interval is pi's. And then your amplitude is 2. So to graph sine, you start in the middle, middle. Now I'm going to graph that with a dotted line since that's not our actual graph. And now since cosecant is the inverse of sine, you need an asymptote wherever sine is 0 because that would make it undefined. And then you just turn the graph up, and that's your graph of cosecant. Now secant is the inverse of cos. So for this one you're going to do 2 pi over the frequency again, then you're going to get pi over 4 as your interval. And then your amplitude is 3, so you start by graphing cos, like that. Dotted line. Now where the cos is 0, you're going to need an asymptote. And you turn the graph up. And that's your graph of the secant. Now for arc sine, you need to restrict the domain so that the inverse is also a function. So arc sine is going to be in quadrants 4 and 1, so that's why it's negative pi to pi. And it's going to be just the same as arc sine, so as regular sine. So you start in the middle, and then for positive, you go up. Then for negative, you go down. You just do it like that. And everything's the same. You get your frequency by doing the same things. But this is arc sine. And now for arc cos, you're going to do the same thing as arc cos. These are going to be your interval. And you're going to start by starting at 1. Then as you go up, you're going to go here into here. And you're going to graph that. And that's your arc cos graph. They're basically, your arc sine and arc cos are basically when you just turn them 90 degrees and then you restrict the domain so that the inverse is also a function.